During the 2026 FIFA World Cup, the stadium set to host the most matches features a retractable roof weighing as much as 20 Boeing 737 airplanes. Back in 2006, while the stadium was under construction, engineers faced an incredible challenge, designing a 1,500-ton roof that could open and close on demand. The problem? It had to sit on a structure with no interior columns and no supporting walls. At the time, this was one of the largest stadiums ever built, featuring the world's longest unsupported steel arches. But there was a major obstacle. The arches were curved at a 30-degree angle, making it nearly impossible to move such a massive roof. Imagine trying to pull the weight of 20 Boeing jets up a hill. Dozens of engineers were brought in. Every possible solution was tested, but none worked. In the end, the winning idea came from an invention created more than 150 years earlier by someone who wasn't even an engineer. Welcome back to the Curious Mind Stories. The stadium that many consider the crown jewel of FIFA World Cup 2026 is AT&T Stadium in Arlington, Texas. Covering more than 3 million square feet, this architectural masterpiece can seat over 80,000 spectators. Its interior volume exceeds 3 million cubic meters, meaning the entire Great Pyramid of Giza could fit inside with room to spare for thousands of people. The stadium is so tall that even the Statue of Liberty could stand inside without touching the roof. Looking at AT&T Stadium, it's hard to believe how it was built. Two 400-meter-long steel arches without interior columns, a 1,500-ton retractable roof, a fully climate-controlled interior, and two massive glass doors as tall as a 12-story building. The project began when the NFL needed a new home for the Dallas Cowboys. The team's vision was clear: build a stadium that could generate revenue year-round, not just during football season. Texas weather made the challenge even greater. Summers are brutally hot, while winters can bring severe storms. The stadium had to function as a climate-controlled indoor venue. Normally, large roofs rely on columns for support. But columns inside a stadium would block fans' views. Architect Brian Trubay was tasked with creating a design that eliminated interior supports entirely. And the roof wouldn't just support itself. It also had to carry the world's largest center-hung LED display, weighing approximately 600,000 kilograms. Combined with the roof, the total supported weight would exceed 2,100 tons. The solution came from a forgotten engineering breakthrough dating back to 1875. While building a railway in Portugal, engineers encountered the wide and fast-flowing Douro River. Traditional bridge piers weren't practical. French engineer Gustave Eiffel designed a giant parabolic arch bridge supported only at its ends. Its strength came not just from the arch itself but from a network of interconnected triangles known as a truss system. Triangles are uniquely stable structures. Under pressure, they may fail, but they don't easily. This same principle became the foundation of AT&T Stadium. Engineers constructed two giant steel arches stretching nearly 1,400 feet. Each arch is approximately 14 feet thick and 35 feet deep. Their enormous weight is transferred into four massive concrete abutments. Because steel expands in Texas heat, special expansion joints were installed between the arches and the concrete supports, allowing the structure to expand and contract safely. 8 months later, the roof structure was complete. The stadium featured an iconic rectangular opening inspired by the Dallas Cowboys' former stadium. But now came the hardest part: creating a roof that could actually move. The retractable roof panels weighed more than 10 blue whales combined. In 1869, businessman Sylvester Marsh developed the world's first successful cog railway to climb Mount Washington in New Hampshire. His design used a rack-and-pinion system, where gears lock into a toothed rail, allowing trains to climb steep slopes. AT&T Stadium adopted the same concept. The roof panels travel along giant rack rails powered by 130 electric motors, each producing 7.5 horsepower. The gears ensure both sides move at exactly the same speed, keeping the load perfectly balanced. The entire roof can open or close in about 12 minutes. Cooling the stadium presented another enormous challenge. The enclosed space holds roughly 3 million cubic meters of air. To manage this volume, engineers installed an astonishing 11,000-ton cooling system. Some of the air ducts are up to 6 feet in diameter. LD air is distributed from above and naturally sinks toward the field, while warmer air rises and is recirculated through the system, creating efficient climate control throughout the venue. To enhance the fan experience, the stadium features a massive center-hung LED screen weighing approximately 600,000 kilograms and containing more than 10 million LEDs. The stadium's glass doors are equally impressive. Standing as tall as a 12-story building, they are composed of multiple insulated glass panels weighing around 86,000 kilograms each. Like the roof, the doors operate using a rack-and-pinion mechanism and require approximately 18 minutes to fully open or close. A stadium of this scale isn't just a sports venue, it's one of the most remarkable engineering achievements ever built. Subscribe for more.